Hello everyone, welcome back to our channel. So today we are going to start second chapter, that is acids, bases and salts. In our previous videos we have completed the chapter 1, that is chemical reactions and equations. We have discussed about all the bases, that how does a chemical reaction take place, what are the things that we need to know from a chemical reaction, how does a chemical reaction takes place, how can we say that a chemical reaction has taken place, etc, etc, how to balance an equation, oxidation reactions, redox reactions, etc. A lot of information was in the first chapter. So if you haven't watched the first chapter, I'll link it in the description. Please go and watch that video as well. So today we are going to start with the second chapter, acids, bases and salts. Let's go through the text and understand it clear. You have learnt in your previous classes that sour and bitter tastes of food are due to acids and bases respectively present in them. So in our previous classes, that means at the class where we got through acids and bases, we have classified acids and bases based on the taste. If they taste sour, we name them as acids. If they taste bitter, we name them as bases. That is what we know till now. Let's have a question here. If someone in the family is suffering from a problem of acidity after overeating, which of the following would you suggest as a remedy? Lemon juice, vinegar or baking soda solution. So if you see, the action of acid can be nullified by a base. So among lemon juice, vinegar or baking soda solution is a base. So it helps the excess acid in the stomach to get neutralized by the base. So we have chosen a basic solution which actually neutralizes the excess amount of acid and gives us instant relief. Which property did you think of while choosing the remedy? Of course, a basic property. Surely you must have used your knowledge about the ability of acids and bases to nullify each other's effect. Recall how we tested sour and bitter substances without tasting them. We have used litmus papers or litmus solutions to say whether a given solution is an acidic solution or a basic solution, depending without tasting. Without taste also we can say, that is because of the litmus solutions. So before proceeding further, I just want to give some information about it, about litmus paper, about litmus, the color of acids in litmus, etc. So in acids, the blue litmus turns into red litmus. When red litmus is kept in an acid, it remains red itself. The phenolphthalein remains colorless in an acidic solution, whereas the methyl orange turns into red. Next, coming to bases. Bases, when kept in a red litmus solution, they turn into blue. The phenolphthalein becomes pink, whereas the methyl orange becomes yellow. So this is the basic information that I wanted to share with you all, which helps us to deal with the further activities mentioned in this chapter. Right? I hope you all are clear with it. Now let's proceed. You already know that acids are sour in taste and change the color of the blue litmus to red. That's what we have discussed. Whereas bases are bitter and change the color of red litmus to blue. So acids are sour in taste and convert blue litmus into red litmus, whereas bases are bitter in taste and convert the red litmus into blue litmus, right? What is litmus? What actually litmus mean? Litmus is a natural indicator, whereas turmeric is also an example of natural indicator. Have you noticed that a stain of curry on a white cloth becomes reddish brown when soap, which is basic in nature, is scrubbed on it? This is because of the basic action with the contents. Mainly a curry would contain turmeric. So turmeric is a natural indicator. So it becomes reddish brown because as the soap is basic in nature, when it comes in contact with turmeric, it turns into reddish brown. Clear? Now, it turns yellow again when the cloth is washed with plenty of water because there is no action of soap over there. So there is no contact of base. That means the soap with the cloth, right? So that's why it turns yellow again. So what are natural indicators? There are two natural indicators, namely litmus and turmeric. You can also use synthetic indicators such as methyl orange and phenolphthalein to test for acids and bases. So we have learnt natural indicators and synthetic indicators. Natural indicators are turmeric and litmus, whereas the synthetic indicators are methyl orange and phenolphthalein. So what we are going to learn in this chapter? So in this chapter, we will be studying the reactions of acids and bases with different types of metals, oxides, etc. that will go through this lesson. How acids and bases cancel out each other's effect, and many more interesting things that we use and see in our day-to-day life. Let's have a basic idea on litmus solution. First, let us know about basic litmus solution. So litmus solution is a purple dye which is extracted from a lichen, and this lichen is a plant belonging to Thallophyta group, division, and is commonly known as an indicator. When the litmus solution is neither acidic nor basic, its color remains purple itself. There are many other natural indicators like red cabbage leaves, turmeric, colored petals of some flowers such as hydrangea, petunia, geranium, which indicate the presence of acid or base in a solution. These are called acid-base indicators or simply indicators. So, litmus is actually a purple dye which is extracted from a plant belonging to the division Thallophyta, the lichen. It is usually used as an indicator to test for an acid or a base. Next. If the solution is neither acidic nor basic, it remains purple in color. There are also some other natural materials such as red cabbage leaf, turmeric, colored petals of some flowers like hydrangea, petunia and geranium from which you can test for acids and bases. That's about litmus solution. Today in this video we are going to know about the chemical properties of acids and bases. Today we'll just know about how does acids and bases are known to us in the laboratory. So acids and bases in the laboratory. Now, what does this activity 2.1 says is that in this activity you are given some solutions and were asked to test with the red litmus solution, blue litmus solution, phenolphthalein solution and methyl orange solution. So among these solutions, the action of litmus on acid or bases is known to us that I have mentioned in the starting of the video itself. So basing on this information, it is easy to fill this table. So given solutions are hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide and ammonium hydroxide. So the action of the litmus solution in these solutions tells us whether it belongs to the group acid or the group base. So let's revise it once again. How does red litmus, blue litmus, phenolphthalein and methyl orange work on acid? So for acids, the red litmus solution becomes colorless. That means it doesn't change its color, whereas the blue litmus solution turns red. Phenolphthalein colorless, whereas the methyl orange, it turns into red. This is the action of acid in various types of litmus solutions or indicators. Now coming to basic solutions. In basic solutions, the red litmus is turned to blue litmus, whereas the blue litmus, it remains colorless. Phenolphthalein turns into pink, and whereas the methyl orange turns into yellow. This is what we have discussed above, the same we have discussed. Now, these indicators tell us whether a substance is acidic or basic by change in color. So, we are gathering or we are grouping these solutions into acid or base depending upon the change of color or the change of color in various solutions, the action of acid and base. So there are also some substances whose order changes in acidic or basic media, and these are called the olfactory indicators. So what are olfactory indicators? These are different types of indicators which help in detecting whether the given substance is an acidic or basic without tasting it. The alternative for tasting is that change in color and also change in order. So with these two criteria, that is with change in color and change in order, we can identify a given solution or a given substance as acidic or basic. Right? So the olfactory indicators help in detecting an acid or base by the change in their order. So the olfactory indicators are finely chopped onions in a plastic bag and also stripped under normal, cloth, vanilla essence and clove oil. These are the examples of the olfactory indicators. Let's see what the activity tells us here. So in this activity they are saying that take some onion chopped into a plastic bag along with some strips of clean cloth, tie up the bag tightly and leave overnight in the fridge or the refrigerator. Now the cloth strip now be used as a test for acid and base. So you can find that these cloth strips change their order when they are present in acidic or basic media. So you can find the distinct between acid and base when kept this piece of cloth in acid solution or basic solution. Next, coming to the vanilla essence. Vanilla essence also changes its order when placed in acidic or a basic medium. Clove oil too acts as an olfactory indicator. Now, which of these, vanilla essence, onion, and clove oil and clove, can be used as olfactory indicators? Yes, all the three can be used as an olfactory indicators. Let us do some more activities to understand the chemical properties of acids and bases. So, till now we have discussed so about how do acids and bases react with metals. We'll deal it in the next video. So I hope you understood what I've taught today. I'll just quickly summarize what we have discussed today in this video. So we have gone through the introductory part of this page and we have seen how does acidic and basic solution react to various types of litmus solution, phenolphthalein, methylene, orange. We have learnt about the natural indicators, synthetic indicators. We have learnt how acids and bases are recognized by taste, without taste, by the help of order change, by the help of change in color, how to group a particular substance into an acid or base. We have learnt about that. We have learnt about the litmus solution. We have known about the acids and base in the laboratory. So I hope you all understood. Thank you for watching and subscribe for more other videos.